All right. Good afternoon. I hope you're still a little awake from my presentation. My name is Laura, as I was presented, and today I'll be presenting some work that I've done together with Florian Schneider and Ali Safri from the Thünen Institute of Climate Smart Agriculture. So, as we've heard a lot about today, soil carbon is a immensely important parameter that is studied in various forms. And as Pete Smith actually mentioned today, some of what is actually maybe missing is this ground truth information. What we've done recently is we've done a literature review combined with some map studies that I'll present today, where we look at the changes in soil organic carbon from published data from repeated sampling in soil carbon monitoring networks. Oh, this button. So the drivers of the interest is that new legislation is coming in and there's a general increasing interest in carbon credit schemes. And overall, we want to know how soil organic carbon changes in space and time and what drives these changes. But we need more data for references and to understand whether the things that we model actually mirror what is happening on ground. Here we go. So what we've done is that we've done a study of published literature focusing on agricultural areas, which includes both croplands, grasslands, and sometimes non-defined agricultural land. We looked for peer-reviewed publications as well as national reports on carbon change in the soil. And then we've also been in direct contact with researchers that we knew had a data set that might not be available in either of those two forms. The data that I'm presenting here has been filtered, so it's only based on observational data, so no digital soil mapping or cringing or anything like this. We've reduced the modeling and the statistics to a minimum to have more clear result directly from observations. And then we were looking for data sets that had good spatial representation of the region that it represents. And we've also excluded long-term experiments because these are very particular agricultural treatments. So we're looking for data sets that represent a general agricultural approach in the region. And then we included only regional and national studies. So things that were at a very small scale were excluded. Oh, wrong way. There we go. So this is an overview figure of the data in time and space where the data was available. And actually, I was surprised how much data was available. However, there are vast differences in how the data is reported. Some sources report carbon content change, some focus on carbon stock change, some only report a relative change, like a 4% increase, a 4% loss. So it's very difficult to compare these resources. Additionally, there are, of course, differences in the sampling approaches, and sampling depth in particular makes it very difficult to compare across the resources. And then as we see, there are varying time periods, understanding how agriculture has changed recently, but also any potential influence of climate change means that it's difficult to compare across time for these different resources for the information. However, this all gives us an overall indication on how carbon is changing in these repeated measurements. And lastly, of course, nobody can agree on the land use definition, so we're working with a general agricultural approach. Here are the reported changes in carbon stock that we found in the literature. On the x-axis, you see the first and the second sampling year. And the dashed lines are the ones that represent not statistically significant, where this is reported. This is another thing that we maybe as a community need to improve a little bit. Often it is not reported whether or not the changes are statistically significant. This might have to do with this being a very difficult thing to assess, but nonetheless, this is actually something we don't report. But overall, we see that there's a spread. Both increases and decreases are found, but quite severe decreases are also found. When we look at the carbon content changes, we see similar spread in both increases and decreases being found in Europe, with a heavier weight on the losses, particularly in the croplands. And then, of course, if both the initial value or final value is reported in addition to the change in the carbon content or stock, we can calculate and normalize to a relative change in carbon content or stock, and thereby be able to compare the different data types we have from the literature. And we see here, again, where this is possible, an overweight of losses in percentage points per year. And the average reaches about 4 per mil, but negative. So that's unfortunate, but on track for the number. Here, I've mapped these changes based on where I've grouped agricultural land undefined and cropland together. And on the right-hand side, I've presented grasslands. What is worth noting is that on average, grasslands, of course, have much higher carbon contents and carbon stocks than the croplands and agricultural lands. So when they're losing a larger percentage, they're actually losing a net carbon that is much larger in the grasslands than in the croplands. However, this is for the topsoil, which is of varying definition across time and space. And also, this is just the most recent data from each region represented. So they might not represent the same time period. It's all a little complicated, but nonetheless, we proceed. Florian and Ali have helped me produce this figure where we've taken maps of carbon change in Europe. Some of you may be familiar with the product from De Rosa that was published in 2023, and as well as the AI for Soil Health Data Cube we've been working with. And in the bar chart, the bars represent the literature value. We've used the national or regional outlines as well as the green land cover to isolate agricultural land for the two data products. And we see that overall, there's a good agreement between both the De Rosa, that is based on Lucas data, and the AI for Soil Health Data Cube in terms of trend. So we see that the regions where losses are found in all three data sources, and the overall magnitude also seems to match quite well. However, the uncertainty on both the De Rosa paper and the AI for Soil Health Data Cube are quite large and typically overlap the zero line. So yeah, there's a lot of uncertainty with these data products. However, we don't actually fully understand the uncertainty associated with the changes reported in the literature, so they might be of similar magnitude. The organic soils are included in the AI for Soil Health Data Cube, which might also add to the magnitude of the change that we see. So for the conclusion, the soil carbon changes that I've been able to find in the literature is widely studied, but the resampling of these sites is quite rare, and the data is growing. Many countries have established soil monitoring networks and are coming with results in the next couple of years, but for now, we actually don't have that much data on actual carbon changes at regional and national scales. Overall, the carbon is decreasing, but increases can also be found both regionally and in certain land management practices. And in general, the different map sources available do agree with the literature. However, the uncertainty is very high. And some of these differences that we do see might be driven by differences in regional and national definitions of both sampling depth and land uses, which does limit the comparison, but it is the best we have for now. Thank you for your attention.